Hello guys, you are welcome back to the reaction zone. In today's lesson, we're going to solve the question on the board making use of Dalton'S law of partial pressure as well as Avogadro's law. And the question is as follows. Unpurified natural gas delivered from the gas field is a mixture of gases with volume percentage as methane 80%, ethane 6%, propane 3%, butane 4%, and others 7%. Calculate the partial pressure of methane if the gas comes from the field at a pressure of 5 times 10 raised to the power 5 Pascal. To solve this particular question, the first thing to do is to itemize the information in the question. The pressure from which the gas comes at the field, which is 5 times 10 to the power 5 Pascal, represents the total pressure. So the total pressure is the pressure of the gas from the field, which is 5 times 10 raised to the power 5 Pascal. We are told to find the partial pressure of methane. This is what we are looking for. But to find the partial pressure of any gas, we need to know the mole fraction of the gas. Why? Because partial pressure is the product of mole fraction and the total pressure. So, the mole fraction multiplied by total pressure is equal to the partial pressure of any gas. And to get the mole fraction of the gas, we need to know the number of moles of that particular gas, as well as the total number of moles of all the gases in the mixture. But looking at this question, we are not giving the number of moles of any of the gases. Instead, we are giving their volume percentages. But let us recall Avogadro's law, that from Avogadro's law, that volume is directly proportional to the number of moles. So what this means is that the volume percentage of each of the components of the gas is the same as the number of moles of each of the components. So this means then that volume percentage is equal to number of moles. So in the case of methane, the number of moles of methane will be 80. Now that we know this, we can find the mole fraction of methane. But to do that, we need to get the total number of moles. The total number of moles in this case will be the number of moles of each of the components added together. That is 80 plus 6 plus 3 plus 4 plus 7, and that will give us 100. Now that we know this, we can get the mole fraction of methane. The mole fraction of methane will be the number of moles of methane divided by the total number of moles. The number of moles of methane is 80. The total number of moles is 100. So the mole fraction of methane will be 80 over 100, which will give us 0.8. Now that we know the mole fraction of methane, we can find the partial pressure of methane. The partial pressure of methane will be equal to the mole fraction of methane multiplied by the total pressure, which will be 0.8 times 5 times 10 raised to the power 5 Pascal. And this is equal to 4 times 10 raised to the power 5 Pascal. So the partial pressure of the thing is equal to 4 times 10 raised to the power 5 Pascal. Thank you for watching and see you in the next one.